Hello everyone, I'm Pratima Samineni representing Group 18. So today we are going to explain our presentation two part, which is two research papers. So I'm going to discuss about a roadmap of agent research in the development paper. So coming to the next slide, uh, this is the paper I'm going to discuss in this presentation. So the introduction part. So there are the few keywords that I'm going to explain in this introduction part. They are agent, agent-based system, and the multi-agent system. So coming to the first part, agent. So what actually the agent is, it is a computer system which has an ability to do flexible autonomous action to meet its design objectives. So there are the three concepts extracted from the definition. There are situatedness, autonomy, and the flexibility. What actually the situatedness is, it is to describe an agent will receive an input from its environment and it performs some actions on it which can affect the environment in some other ways. For examples, there are the examples for this situatedness is the physical world and the internet. It is often found in the expert systems. When it comes to the example of the expert system, uh, MYSIN, which receives information from a user who acts as a middleman instead of the sensors. And we're coming to the autonomy part. It is one of the difficult concepts. It refers to the state of a system that performs its action without the human guidance. Examples for the autonomy are thermostats, nuclear reactor control systems, and Unix program. Autonomy is also called as a non-agents. And the third part is a flexibility. It is to consider that a system is flexible. It should satisfy three objectives. Those are responsive, proactive, and the social. We're coming to the agent-based system. It is one of the computational models and is defined as having one or more agents. It is implemented without any use of software structures that correspond to agents, but it is expected to be designed and implemented in terms of agents. Agent-based system is one where a single agent acts as an expert assistant to the user who is using the computer to perform some task. And the third part in this introduction is like a multi-agent system. It is designed and implemented as multiple interaction agents. These systems are the best examples of problems that have multiple problem solving methods, like perspectives and the solving entities. This multi-agent system is going to be explained briefly in the second part of the paper by my teammate. So coming to the next slide, which is all about the autonomous agents. So here in this slide, there are the few keywords that I'm going to discuss. Those are artificial intelligence, OOPS concepts, and the concurrent object-based systems and the HCI design. So these are the main contributors for the autonomous system. So coming to the artificial intelligence, in this, and also we have object-oriented programming and concurrent-based system and the human-computer interaction design. To learn more about the study of the artificial intelligence in autonomous agents, these are the built artifacts that are considered as agents when they respond and act in their environment. In the year 1970s, the most closely related area of research actively related to autonomous agent was artificial intelligence planning. So the period of this artificial intelligence planning is from 1970s to the mid 1980s. This AI planning research is a subfield of AI. This research is mainly focused on how to represent the required for the actions and the planning for the algorithms. By using the first principle techniques, the researchers are unable to build reactive agents that can respond to changes in their environment. So this is all about the autonomous agents. So I'll briefly explain about this in the next slide. So coming to the layered agent architecture, so in this we have the horizontal layering and the vertical layering. The researcher here, yeah, so the researcher named Brooks developed the subscription architecture, which is also called the agent control architecture. To explain briefly about this, the agent control architecture, it is a task accomplishing behavior. In the year 1990s, most of the researchers found that the reactive architectures were well suited for problems, but not for the others. So, in order to uh, build an architecture to support both deliberative and the reactive approaches, many researchers started research on the hybrid architecture. The hybrid architecture will support both the reactive approaches and the deliberative approaches, while the subscription architecture and the agent control architecture only satisfy for few problems. So it is organized into layered hierarchy where the lower levels represent fewer abstract behaviors and the higher layers represent the more abstract behaviors. So in the left side in the diagram we can see the first diagram represents the subscription architecture, while the second is like agent control architecture. So when we look into the behavior architecture, in that every behavior acts as a finite state machine that maps one input to the one output. In some versions, the mapping is achieved via situation and action rules. There are few disadvantages in this architecture, like it is hard to check how reactive agents are designed, and also how the decisions are taken based on a local information, and also it is difficult to see how such decisions could be considered. And the last one is like if the agents does not have their models in the environment, they must have some information in the local environment, otherwise they are unable to determine the acceptable action. To deal with this information, there is another architecture which is a subscription architecture. It has a three layers. So while coming to the lowest level of this architecture, which is also called as a reactive layer, it is used to make some decisions about what to do based on a raw sensor input. Well, coming to the middle level, it deals with the knowledge level views of the agent's environment by using some symbolic representations. And while coming to the upper level, it deals with the social aspects of the environment. So this is all about the subscription architecture and the agent control architecture and the behavior architecture. So we're coming to the next slide, which is an object and concurrent object systems. Here, we can say that the objects do it for free and the agents do it for the money. So here, I differentiated what actually the object is and the agent is and how they are interlinked. And also, I explained the object-oriented languages and its concepts. So we're coming to the first, like object. What actually the object is, it is also known as a computation entities that encapsulate some state, and then they can be able to perform some actions or methods on the same state. So these objects are communicated by message passing. There are some differences between the agents and objects. So like object-oriented programming is based on this encapsulation. When we first investigated, like the first difference between the object and the agent in the OOPS cases, the object holds a decision which is used to invoke the method, while in the case of the agent, the decision lies with the agent that receives the request. So this is the main first difference between the object and the agent. While coming to the second difference, there between the agent and an object, there is an autonomous behavior. On the other hand, the third difference is that agents are each considered to have their own thread of control. So the objects are having the OOPS concepts like object-oriented languages. So here we can see in terms of programming cases, we can consider an example as Java. So the instant variable in Java, the instance variable are declared as private, which means that they are accessible within the object. When the variables are declared as public, that means they are accessible to everyone. So most of the variables are declared as private. It is the best practice. For example, if your method considered as M, it is available for all the objects to invoke. They have access to do whatever they wish. At the same time, the object does not have the responsibility to know whether the method was executed or not. Mom a family with mother and two daughters. Red heart or mom heart with stars. And we're coming to the next part, human-computer interface. There are a few keywords in this slide. Human system interface, human machine interface, and the man machine interface. So these are these are the synonyms for the human computer interface. So we can also call it as this. What actually the human computer interface is, it is also known as these three things. In this, there is a interaction paradigm called as a direct manipulation, which is used to act as an interface between a user and a system, a computer. Examples for this is a computer programs that we use in our daily lives, which is a MS Word and the Excel and PowerPoint and so on. So the computer program which takes a responsibility to perform some task instead of depending on the user to do some action, they are considered as semi-autonomous agents. These agents are considered as expert assistants. So there are few key figures in this development of agent-based interfaces. To date, most of such agents have been used in information management systems, specifically email managers, active news readers, and the active worldwide web browsers. The human computer interface or the human system interface or human machine interface, overall they're used as a synonyms for this. So it consists if the interface called as interaction paradigm, which translates the user input to the commands and send back the same commands to the user as in the form of result. Uh, so here we can see that some batch processing. So it was the dominant model in 1950s, in which the user specified all details of the task that were executed them and received some results in an hour or more than an hour when the processing was completely done. So here we can see in the diagram, like on the left side, we can see that is a human, and on the right side, computer. So in between, we have a computer, human computer interface, and we can see some inputs are coming from the human to the computer, and the virtual feedback is coming, like moving from computer to the human as a result form. Well, coming to the last slide about the issues and future directions. In terms of agent architectures, particularly layered and hybrid architectures or practical reasoning architecture, continue to be focus of considerable research effort in the agent field. So there are few languages built to implement MAS. There are like Kongrog language, the concurrent meta M programming language, and the language called as an April. So to briefly know about these languages, so the first language includes features for prioritizing concurrent process execution, interrupting execution when certain conditions are met, and dealing with some actions. The second language, it is also called as a high-level language, which is used for modeling distributed and concurrent systems. This language is an operational model for several metatem, which is called as a framework for executable temporal logics. In present, like nowadays, most of the architectures have been implemented in an ad hoc manner. So this is all about the issues and the future directions. So the next part of the first paper will be continued by my teammate. Thank you.
Thank you. This is Gautam from Group 18. We will continue the part 1 discussion. In this, we are going to discuss about distributed artificial intelligence, DAI. It is actually a subfield of artificial intelligence. It is used to compute with DAI. Many nodes or learning agents which are independent of one another are distributed across the globe. These agents are used for solving the tasks at a micro level. Parallel processing enables this system to make use of all the componential resources. So it makes use of each and every resources which are implemented in this analysis process. Due to this processing power, huge data sets can be analyzed quickly, with each part being analyzed by a separate node. The main areas in DA are: one is multi-agent system and another one is distributed problem solving. The multi-agent system is a system in which several interacting and intelligent agents are pursue some set of goals or tasks which are beyond their capabilities and try to achieve those things. In this, coordination is very important, while distributed problem solving is nothing but the task of solving particular problem that can be divided among different agents that discuss on the problem solving techniques. It is a parallel process. Each agent will take some part of the problem and try to solve those things. Coming to next part, multi-agent system. Multi-agent system is nothing but a set of agents which are grouped together, which communicate with the environment to achieve the common goals. Example, expert assistant, which are agents acts like an expert assistant to the user attempting to fulfill some task for computer. Mostly these are used in computer applications to address users with basic questions. The main characteristics of these masks are: agent won't have complete control over any environment. They have only partial control, and they have only partial information available with them. There is no global system control, and data is decentralized in these multi-agent systems. Coming to next slide, there are different ways of communication available for these multi-agent systems. For providing the communication, we have different methods implemented, and among them, these are few methods which are using now. Agent communication languages, which provides means of exchanging information, knowledge. Number of languages have been developed specifically for agent communication. The knowledge sharing effort is the another method used for communication to develop the technical infrastructure to support the sharing of knowledge among autonomous information bodies. The goal of this effort is to develop the technology that will enable researchers to develop new systems. And coming to next one, knowledge query and manipulation language. It is a cumulative. It is mostly used for providing some user-friendly information in the computer software to make the users to understand the language. And the foundation for intelligent physical agents is the non-profit association. Its main aim to promote the success of emerging agent-based applications, services, and the equipment. Apart of the coming to next slide, apart of these advantages from the multi-agent system, there are few problems while implementing these systems. Few of them were how to create, describe, or delete the intelligent agents, and we have to allocate the problems among all these agents. We have an issue to divide the problems and allocating to them. So next one is how to activate agents to communicate and interact, and what language it needs to use, and what and when it has to communicate, and how to make sure the agents are making right decisions and avoiding harmful interactions, and how to design this technology platform, develop methodologies for mass, how how effectively manage the allocation of resources. These are few problems which usually faced during the implementation process of multi-agent system. Coming to next slide, regarding the applications. Agent technology extends the scope from research labs and universities to solve the real-time problems in the domain of industry and communication applications. There are different places where these multi-agent systems are implemented. Some of the examples like electronic business, bioinformatics, computational biology, monitoring and controlling, education, resource management, and these all are categorized into four different parts. They are industrial applications, commercial applications, entertainment, and medical applications. Coming to next slide, we will discuss each one in deep. So industrial application is one of the first to be developed, and today agents are being applied in wide range of industry systems. For example, manufacturing is the one where where we are using it for designing the products, collaborative design, scheduling and controlling the manufacturing operations, controlling a manufacturing robot, and etc. These are the uses of multi-agent system in manufacturing. Similarly, for in process control, it is the natural application for agents. It is implemented in electricity transport management and particle accelerator control. It is one of the earliest field test multi-agent system implemented. And coming to telecommunication, recently added features in telecommunication provide additional functionality for basic communication. Because of these additional features, we are having a lot of information transferring between different people. So tracking and controlling these information now become a big issue. So the agent-based systems are implemented to solve this by implementing like network control, transmission switching, service management, and network management techniques. Similarly, like air traffic control and transportation systems also have different use cases by multi-agent system. Those are discussed further in the next slides. Medical applications. Medical applications is one of the rapidly growing domain in computer science. Day by day, the new applications are being found in this domain, and few recently deployed applications are patient monitoring and healthcare. This patient monitoring is very useful in some situations like where doctors need monitoring minute by minute status of the patient. These tasks can't be achieved by the nurses or the human staff available there. So the multi-agent systems were used in these scenarios. Similarly, while maintaining the healthcare records, it's difficult for the humans to track all the records of the each and every patient. So by implementing these techniques, it will automatically map down to the individual patient and involved in the patient care process. Coming to next slide. Here are commercial applications. In these commercial applications, these are mostly related to information management, focus on large scale market, where industrial applications are focused on small markets. So these are mainly into information management techniques. These information management mainly focus on filtering and gathering of the information, because every day we are getting huge amount of data from various sources like mails, through internet and other posts. So we will use only a small portion of the information which are relevant to us. So the filtering of information is must. And similar way, the volume of information available in prevents us from answering specific questions. So information gathering also needed. So this information is further used for analysis and different portfolios. Coming to electronic commerce, it is used in different places where we can find some online tools for bargain finder, which can find cheap products for use and personal shopping assistant, which are mostly used in our regular shopping apps. Coming to business process management, it will mainly use for the manager level people in the organization to take the right decision. Coming to entertainment applications, even these technologies do not leave the leisure applications. Like it is not less than usage of some serious computer applications. Applications such as computer games can be extremely challenging and more profitable. So games use these agent technologies. Mostly they create the creatures in this one. Creatures are created which provides a rich and simulated environment containing a number of synthetic agents that a user can interact with in real time. This is the most famous multi-agent system nowadays using, and interactive theater and cinema is also one of the things which are implementing nowadays. Agents that play a role of humans are known as believable agents. This is used to create the role of the heroes which are similar in the real life. Those are used in these are the few implementations of mass in different applications. Coming to next slide. Future directions, using multiple autonomous agents that interact in various ways to solve an individual or a group goals is useful software engineering abstraction. These abstraction helps software engineers to do work more cheaply. The issues while implementing these techniques are lack of systematic methodology, lack of widely available industry strength multi-agent system toolkits, and the use of for using these things, the humans needs to believe the systems, because the agents must maintain the balance in not disturbing the user every time and exceeding their limits. Each agent must have some limits. It has to know its limits to do their work. Coming to last slide conclusion. Over the last 2 decades, a number of conceptual changes has been made in designing and implementing autonomous agents. Multi-agent systems helps in providing proper solutions for designing of complex and distributed computation systems. These multi-agent systems and the partial systems combine together to meet the needs of entire applications. So by using the agent-based applications, we can achieve the task for highly huge data information easily. So my friend will continue the rest part of the presentation. Thank you.
So hello all, my name is Murali Krishna Bombisetti, representing Group 18. So today I'm going to discuss about the research paper Multi-Agent Learning for Engineers. So introduction. Multi-agent learning could be used as a design technique for distributed control. It is a branch of control theory concerned with the design and analysis of many controllers that work together to meet a particular design objectives. We believe it can aid in design of the distributed control system by decreasing the complexity of each controller, accounting for uncertainty and allowing for distributed interactions between controllers. Below are some of the issues that distinguish the engineering perspectives from descriptive and predictive perspectives. From an engineering standpoint of view, the goal of multi-agent learning is to aid in the design of the complex systems that incorporates numerous agents. We finally provide an outlook to the engineering agenda and the challenges that it poses to multi-agent learning. So why multi-agent learning? The purpose of multi-agent learning from an engineering perspective is to therefore assist the design of a complex system that includes multiple agents. It is well known that creating optimal distributed control system is a challenging task. Limited communication capabilities, local and dynamic information, defective components, and an unclear, if not hostile environment all complicate the effort. In general, sending all information to the command center that can process it and disseminate commands is not practical. A multi-agent perspective allows you to see the larger system as a collection of similar interacting parts. As a result, the optimization problem is much simpler than the centralized problem. Although it is still related to other connected components, nonetheless, the idea of developing a centralized optimal policy is less intimidating than the prospect of the self-organization into a suboptimal Nash equilibrium.
Only voice is breaking.
Descriptive or predictive or engineering. The economic game theory literature has influenced a lot of multi-agent learning research.
Hello.
This does not rule. Yes, Gautam?
Hello.
Yes, Gautam? It does not rule out the possibility of using
Hello.
substance as a source of procedures. Source of procedures. Instead of it emphasizes the significance of understanding what is the problem. What is the problem? When used in material engineering systems, various economic concepts that serve as descriptors or predictors in the literature become design considerations. There are 5 parts in this. One is defining the game, Nash equilibrium, performance, convergence and averages, limited information and costly communication. Fifth one is learning dynamics and bounded rationality. So defining the game, we have mentioned that multi-agent learning could be a good way to solve the challenges we discussed before, but we haven't yet defined a game in which to use it. When imposing a multi-agent perspective on a game, the basic features of players, strategy spaces, and player utilities are all design concerns. Agent activities in reactive settings that cover overtime is overtime are a critical reality that a design methodology must address. A one-shot game, a repeating game, or a stochastic game can be used to capture such dynamics by reflecting the effects of a strategy over a numerous time steps. A repeated game provides a richer structure. Stochastic games are in a more natural way of stimulating simulating dynamics. Learning in this scenario is rather difficult, especially when it comes to achieving a Nash equilibrium and regret reduction. Following the specification of players and strategy spaces, another design consideration is the definition of agent utility functions. Even in the ideal case of centralized purpose that everyone agrees on, there are essential factors to consider when distributing this goal among the many players. So next we are going to discuss about Nash equilibrium. Different arguments are required for the importance of Nash equilibrium in design systems. We believe that the best way to understand how a credible this equilibrium process might converge to Nash equilibrium is to look at a work like this. For example, in a message passing technique is used to communicate the equilibrium of a specific graphical game. Because this method is so complicated, it appears that a learning scheme that converges to it must also be quite complicated. Next, we are going to discuss about performance, convergence, and averages. From an engineering standpoint, convergence of learning algorithms should not be a goal in and of itself. In comparison to the non-convergent scenario, convergence may result in loss of efficiency in terms of player utilities. In a network, an example is which develops a routing algorithm that leads to the desirable Wardrop equilibrium, which is a Nash equilibrium in the relevant context. In the absence of huge teams, worst case or the very least risk averse performance criteria are more appropriate for routing. Network routing. Simulated multi-agent learning can surely be used offline as virtual experiments to fine-tune a decision-making policy. However, a system that provides guarantees on something more than average performance is still needed. Next, we are going to discuss about limited information and costly communication. The information available to each agent is an important concern in multi-agent systems. Agents, for example, may have access to actions of other agents or simply their own payoffs. Uncoupled learning occurs when there is an absence of such utility information. It's worth nothing that for both technical and economic systems, a functional statement of usefulness is a frequent unattainable. Next, we are going to discuss about learning dynamics and bounded rationality. Understanding how agents learn in games is important for descriptive social models. Multi-agent learning has a large number of different adaptation processes. This could explain why most economic processes only demand a small amount of real-time processing power. Agents are programmed components in engineered systems, therefore, their specification becomes another design choice. Multi-agent learning design considerations are far from complete, and they will continue to expand as long as economic techniques for engineering challenges are investigated. In theoretical networking world, the idea of giving incentives through pricing has grown very appealing. Eventually, creating such mechanism appears to be difficult undertaking. Next, concluding remarks, the engineering agenda. We describe two additional aspects that are particularly important for engineering systems. These include robustness and domain knowledge. Robustness means resiliency of a system to variation in the parameters of nature or the expected input. It is perhaps most important in the dynamical setup where there might be transient disturbances. Domain knowledge is a vital element of systems engineering specification. Efficient incorporation of domain knowledge in planning and in artificial intelligence is a long-standing challenge. Developing rigorous methods to describe the specifications of multi-agent systems is crucial to understanding, analyzing, and simulating them. For engineering systems, there are various characteristics of robustness that are critical. To begin with, robustness implies that there are some performance guarantees that will stay true even in the most adverse conditions. This could be done, for example, by an online learning approach that minimizes regret and provides some performance guarantees. Second, robustness indicates the performance may be guaranteed in relation to set of specifications. This means that we can guarantee particular performance levels if we limit the set of opponents and the real environment to a specific set of conceivable opponents and environments. So that's it about our presentation. Thank you.
Thank you, everyone.